us consider the three interesting cases where from a tower of 50-meter high a body is projected. So obviously the body can be projected primarily in three ways. One is horizontal, the other is making some angle in the upward direction with this x-axis. Suppose we are taking this as x-axis, this way we are taking it as x-axis, and this way we are taking it as y-axis. So with the horizontal, in the upward direction it has been projected, and in the third case it has been projected in the downward direction with the x-axis or with the horizontal at an angle of 45 degree. Over here also 45 degree, and over here it has been thrown purely horizontally. We are not considering those cases when the body has been projected purely vertically along the y-axis. We have all done those cases. So generally these are the cases you will come across when you are doing questions on projectile motion. And now let's say we have to find how far from the base of this tower the body will fall. In this case it falls over here, let's say it strikes over here, we call it as AB, and in this case it goes over here, this is AB. In all the three cases we have to find what is the distance at which the body strikes the ground from the base of the tower. So in all these cases we know that in the upward direction we are taking the vectors as positive, in the downward direction we are taking the vectors as negative, acceleration along y-axis is g in the downward direction, and acceleration along x-axis, that is equal to 0. Now let's say we have to find now, the first case is we have to find this distance, that is how far this body is going to strike the ground from the base of the tower. So what we do is we use from O to A, that is O is our initial point of observation and A is final point of observation. Sorry, this should be B only. O to B, that is O is our initial point of observation and B is our final point of observation. We use Sy is equal to Uyt plus half Ayt square. That is along the y-axis we are talking about. When we are talking about the displacement on y-axis, we shall not bother about how much it has gone in this direction or in the reverse direction. We are just bothered about whether the body has gone down or whether the body has gone up. So in this case, the body has gone down by 50 meter. So displacement on y-axis, it is in the downward direction. Displacement is a vector quantity, it has an arrow on its head. So this is 50 meter in the downward direction, so that's why it is negative, minus 50 uy. All the velocity has been given purely along the x-axis. Purely it has been thrown horizontally. So it means there is no initial component of velocity along the y-axis, that is the vertical direction. If there is a person who goes purely along the x-axis, say let's say this is x-axis, this is y-axis, let's say a person has gone 10 meter along the x-axis. How much he has gone along the y-axis during this time? He has gone 0 meter along the y-axis. If a person has gone purely along y-axis, that is 5 meter, how much he has gone along the x-axis during this time? He has gone 0 meter along the x-axis. That is, if a vector is aligned purely along x-axis or y-axis, then its component on the other axis is 0. Similarly over here, all the velocity has been given purely along the x-axis, so that's why uy is going to be equal to 0. Half ay is, we are taking it as g, it is in the downward direction, that's why it is negative, and we have taken g as, instead of 9.8 meter per second square. For ease of calculations, we have taken g as 10 meter per second square, and it is in the downward direction, so that's why it is negative into t square. Now t is not equal to 0, so this t and square, this will go off, and t comes out to be root 10 seconds. Once we know the time from here to here, then certainly we can use what is this displacement, that is Sx we can find out. Sx or Sab is equal to uxt plus half axt square. Now we know acceleration on the x-axis is equal to 0, so this is equal to 0, this goes off. Ux, what is ux? This is 20 root 2. 20 root 2 into what is the time from here to here or from here to here. When the body has gone from here to here, it has also gone from this coordinate to this coordinate along the x-axis. Time is a scalar quantity, it doesn't have a direction. If it has taken any time from here to here, it has taken the same time in moving from this coordinate to this coordinate of x-axis. So time is root 10 second. So Sx is equal to ux into t. Ux is 20 root 2 into root 10. So we get the value of this distance, that is how far it is going to strike the ground. Now coming to case number 2, what we can do is, once again, we can take this as x-axis, we can take this as y-axis, and we over here we see that this velocity is between this and this axis. So obviously we can break this velocity into its components along the x-axis and along the y-axis. If we have this as x-axis and this as y-axis, so this is x dash, this is y dash. If the velocity is in this direction, so obviously its components, they are going to be in this direction and in this direction. If the initial velocity is in this direction, then we can break it into components like this. One component is this way, the other component is this way. If the body is given a velocity in this direction, like this and this, that is same, so we can break it into components. One component will be in this direction and the other component on y-axis will be in this direction. If the velocity is given in this direction, then its components, they are going to be like this along the x-axis and this along the y-axis. Over here the body is thrown like this, so we can break into components like this. One component here, the other component here. So 20√2 meter per second can be broken along the x-axis and along the y-axis. If this is 20√2 meter per second and this angle is 45 degree, so this component is going to be 20√2 cos 45 degree and this component is going to be 20√2 sin 45 degree. We know sin 45 degree is equal to cos 45 degree is equal to 1 by √2. So when we put the value of 1 by √2, so this is 20 into √2 into 1 by √2, so this comes out to be 20 meter per second. Similarly, this component along the y-axis, this will also come out to be 20 meter per second also. So over here, what we can do is, we can break this velocity in two components. One component, so this component is 20 meter per second and similarly this component is also 20 meter per second. So now once we have broken this velocity in two components, one is along the x-axis, the other is along y-axis, then we can use the equation of kinematics, that is S is equal to ut plus half at square along the y-axis. So that assumes a form of Sy is equal to uyt plus half ayt square. So from there we can find the time of flight, that is how much time it will take to reach from here to here. Once the time of flight is known, then we can find Sx is equal to uxt plus half axt square, ax will be equal to 0, and from there we can find that is how far from the base of the tower it is going to strike the floor. Let's write the equations. So if we call this as O, from O to B, we say Sy is equal to uyt plus half ayt square. What is Sy? From here to here along the y-axis it has gone down, so it is minus 50. Uy, initial velocity along y-axis, initial velocity at O, initial velocity along y-axis, this is the y-axis, it is in the upward direction, the upward direction it has to be taken as positive, so this is plus 20 t plus half ay, axis on the y-axis is g. In the downward direction, it has taken as negative, and the magnitude of g we are taking as 10 meter per second square, so it comes out to be minus 10 into t square. So this is going to be quadratic equation. So solving the quadratic equation, you can find the value of t from here. Once you find the value of t, then SAB, that is this is equal to Sx only, is what? Uxt plus half axt square. Ax you know that is equal to 0, so Sx we have to find out, that is A to B. Ux is what? Ux is 20, and t from here you can put the value of over here to get the value of what is this distance at which it is going to strike the ground. So in case number 3, we can break the velocity into its components. One is horizontal this way, it will come out to be 20√2 cos 45. Cos 45 is once again 1 by √2, so this will come out to 20 meter per second. And similarly along the y-axis it will be in the downward direction, 20√2 sin 45. Sin 45 is once again 1 by √2, so this is also going to be 20 meter per second. So this velocity component, so this velocity is broken into its component. One is along the x-axis, the other is along y-axis. Then as we had done over here, let's say from O to B, if we consider that is this is our initial point of observation, this is final point of observation, and let's use Sy is equal to uyt plus half ayt square. So from here we can find the value of time. Sy is going to be minus 50. From here to here it has gone. Uy over here we see that is now initial velocity along the y-axis is in the downward direction. Over here it was in the upward direction, we had taken this as plus 20. Whereas over here it is in the downward direction, so it is going to be minus 20 into t, because in the downward direction we are taking the vectors as negative, plus half ay, axis on the y-axis is always in the downward direction, and downward direction we are taking it as negative, The value of g we are taking it as 10 meter per second square, so it is minus 10 into t square. So from here, once again a quadratic equation, we can find the value of t. Please understand the time over here and time over here, there will be different values. If we compare this equation and this equation, there is only one difference, that is over here is plus 20 and over here is minus 20. But this difference is going to alter the value of time. So once the value of time is changed, this distance will also change. So SAB is Sx is equal to ux into t plus half axt square. Ax is 0, so it is going to ux. Ux is what? 20 into t. T from here will put the value over here, so we'll get the value of SAB. So in all these cases, we can find what is the distance from the tower at which this body is going to strike the ground. So in all these cases, what we have done is primarily we have broken the velocity along x-axis and along y-axis. Then we have found the time of flight using the equation Sy is equal to uyt plus half ayt square. Once we find the time, then we can find the value of Sx, that is Sx is equal to uxt plus half axt square, Ax is equal to 0. From the previous equation, we can find the value of time and put it in this Sx is equal to ux into t to find, that is, how far from the base or tower this object or this body is going to strike the ground.